review covers is factoring. Now, we did a factoring flip chart in here. So if you need to refresh yourself on factoring, pull it out. Go back through it. Number one, whenever we factor, step one is to always look for a greatest common factor. And number one has a greatest common factor. What is it? X. So that's what we're going to pull out first on this one. Okay, so if you didn't, please do so now. Okay, now, hopefully you recognize this is a sum of cubes. Okay, so let's go. Okay, we'll do it here. Let's go back over our pattern for our sum of cubes. Now, remember, it's SOAP. SOAP is what helps us get the signs right. SOAP stands for the first one is the same, the second one is the opposite, and the last one is always positive. So that helps us remember our signs. Now, the cubed root goes here, and the cubed root goes there. And then we square the first one, do the product of the two, square the last one. So it's square, product, square. All right, so that is our process for a sum of cubes. So what is the cubed root of x cubed? X. What is the cubed root of 8? 2. All right, let's do our signs. This is plus, so same, opposite, always positive. Now, here we do the square of this one, so it's x squared. Here we do the product of the two, it's 2x. And here we square the last one, so it's 4. Okay. I'm going to give you one more to try. This one's going to be a subtraction one, okay? And I'm going to give you a little bit more in terms of coefficients. So let's do 8x to the 6th minus 27y to the 3rd. So this has a little more going for it. You try that one now. Okay. Ask me for help if you're not sure what to do. Okay. All right, so let's take a look at your U try. Now, this one factors a little bit differently because we have higher exponents. But we start off with that pattern of our signs, same, opposite, always positive. Okay? And then we look at this and we go, what is being cubed to get 8? 2. Now, with the exponents here, with a variable raised to an exponent, you can always take this exponent and divide by 3. So that gives us x squared that's being cubed. So an x squared goes here. Check and see if you put the little 2. And then here, the cubed root of 27 is 3. And this is y.
This is a separate one, right?
Yeah, this was an extra one I gave you.
Alright.
Okay, so then we square the first one. Now when we square the 2, we get 4. And when we square an x squared, we get x to what power? The 4. Then we do the product of the 2. 2 times 3, 6. And then x squared times y. And then we square this last one. 3 squared is 9, y squared. Okay.
Why wouldn't it be 2x squared minus 3?
Here? Okay. Because this has a y to the third, we have to have the y there also.
I know what I did. I took the cube root
Okay.
and then I made it regular.
All right. Now, this one's interesting. We haven't done one just like it, so I would kind of be surprised if you got this one without any help yesterday. So what we can multiply to get 16 that we can add to get 10 is 2 and 8, right? 2 times 8 is 16, 2 plus 8 is 10. But it has to be x cubed, because when we multiply this and this, when we add them together, we have to get a 10x cubed. So this middle term tells us about what those variables have to be. Those variables have to be raised to the third power. Now, if we check all this works, because x cubed times x cubed is x to the 6th, 8x cubed plus 2x cubed is the 10x cubed, and 8 times 2 is 16. Now, it would be nice if we were done. But look, what did we end up with? The same thing we had over here. This one doesn't go any further. The first term is a perfect cube, but 2 is not a perfect cube. Let's remind ourselves about our perfect cubes. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125, and 6 cubed is 216. Those were the ones that we told you would need to be able to recognize on your Algebra 2 test coming up Tuesday. So this, it won't factor anymore, it's done, so we can just copy it down. But this factors further. This is a perfect cube, this is a perfect cube. It is a sum of cubes. So same. Opposite, always positive. The cubed root is x, the cubed root is 2. We square this first one, we do the product of the 2, and then we square the last one. So that is the correct answer. This is your correct answer to number 2. This was the correct answer to number 1. Yes, ma'am.
What if I just factored it like the normal way?
Okay, so let me come see what you did. And it just may be that you need to take it a step further. Let me see. Yep. Okay. So, this is an x to the fourth. And to get an x to the fourth, when we start factoring it, it has to be x squared times x squared. And then you ask yourself, what can you multiply to get positive 4 that you can add to get negative 5? So we know they both have to be negative because we're multiplying to get a positive, but we're adding to get a negative. And what are those two numbers? Negative 1 and negative 4. Now, both of these factors factor further. The first one is a difference of squares, so it factors to x plus 1 times x minus 1. The second one is also a difference of squares, and it factors to x plus 2, x minus 2. So, I don't feel like copying those down. There we go. There's the factors. So, if these are my factors, what are my roots or x-intercepts or zeros? So when your teacher asks you for any of these, roots, x-intercepts, zeros, it's all talking about the same spot on the graph. We would write our answer a little differently, but it's the same spot on the graph. So if this is a factor, x plus 1, what is the x-intercept that goes with that? Negative 1. Let me change to pink so you can see it a little better. Alright, if this is the factor, x minus 1, what is the x-intercept? Positive 1. If your factor is x plus 2, what is your x-intercept? Negative 2. And x minus 2 will give us positive 2. So the first thing you have to do is find those x-intercepts. Okay, the second thing we have to do is graph our end behavior. Okay, so those are our arrows, guys. Those are our arrows. So we got to come back up here, and to find the end behavior, we look at it is a positive leading coefficient and an even degree function. So this one, it rises to the left and rises to the right. Because it's a positive leading coefficient and an even degree function. And then the third thing you have to look at is your root behavior. So, root behavior means, does it pass? Is it tangent? Or does it pass with inflection, with an inflection point? Okay? Now, passing is a first degree. If your factor is raised to the first power. Tangent, your factor is raised to the second power. Passing with an inflection, your factor would be raised to the third power. All of these are raised to the first. It's an understood first power. So we're just going to pass, 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 pass. Everything's passing. Okay, we need to put our phones away, please. Yes, ma'am.
For that one, I didn't simplify it further. I still got it to the arrows going up. Would I still get if I did that on a test or anything? Would I get half credit or would it
You
just
get some, but we assign points for every single x-intercept.
Mhm.
We assign points for the end, so you get full credit for your end behavior. And we also assign points for what's happening at every single intercept. So if you were missing some of your intercepts, you would lose points for that.
Okay.
Yes, ma'am.
How do you determine the root behavior, the pass and the tangent?
Okay, so with the root behavior, how do we figure this out? So what we do is we look at our factors. Every single one of these factors was just to an understood first power. And so when they're to the first power, it just passes straight through. straight through. But this one has a 2 and a 3. So let's do that one and we'll talk about what happens there so we can see what happens when it's a 2 or a 3. Yes, ma'am.
How do you know what arrows to do at the end?
Okay. From our notes the other day, what day was that? Tuesday? Monday? This one, right here. Okay, so I'm going to snip this. This tells us what to do with our ends. Let's see. I don't think it's gonna let me move it down
Like,
here,
how
but
do
I'm
you
gonna
know
try.
if it's even or odd?
How do you know if it's even or odd? Okay. To tell if it's even or odd, this one you could count right here. 1, 2, 3, 4. So 4 is even. Or because this one at first was just added and subtracted, you can find the biggest one. But if we start off with a multiplied like this one, to find it, you have to count. 2 plus 3 more makes 5. So this one has a degree of 5 and a negative leading coefficient. So if it's odd and negative, it rises to the left and falls to the right. Yes, sir.
Just to be correct, like whenever it has to be factored, you count the degree after it's factored.
You can. Yep. 1, 2, 3, 4. Yes, that will always work. Okay. So we need an x-intercept at -1 and an x-intercept at +2. Okay, so for step 1, x-intercepts on a graph. Step 2, in behavior. So negative leading coefficient, degree of 5. This tells me from this left one, it's going to go up, and from the right one, it's going to go down. That's what a negative leading coefficient for a degree of 5 tells us. Now, the factor -1 is squared. So when it's squared, it's tangent at that point. So this one right here was squared, so it's going to bounce back. It will not go to the other side of the x-axis. Okay? Now the next one, the next factor is this one, +2. It gives me the x-intercept of +2, and it's to the third power. So a third one passes with the inflection. So this one right here is going to have a squiggle in it. So I kind of need to erase that bottom part because I need it to go from concave up to concave down. It causes a squiggle in your graph. And if you're not good at drawing that, then what I want you to do for your teacher, if you're not good at making it squiggle, I want you to go like this. This is an inflection point. Just tell your teacher, that's an inflection point right there. I'm not good at squiggling, but please know what that is. Okay? And you'll get full credit. And if you don't, bring your test to me, and I'll talk to your teacher for you. Okay? All right. Okay, let's go do those things that were at the bottom that I covered up accidentally. I guess what I covered up was, where can I stick this? I'll stick it right there. The x-intercepts of these were the, we can just write them. -2, 0, -1, 0, 1, 0, and 2, 0. The degree of this function we talked about, it's 4, and it has a positive leading coefficient. As, oh, looks like they put positive in, did I put positive infinity first on this?
Yes.
I don't even like it. That's confusing. I like negative infinity first. Man. So if you guys got confused on that part, that's my fault. I should have done it the other way.
Well, they both could have been. Yeah. They both
Yeah, on this one, they both are the same. But usually I put negative infinity first because I'm a left to right kind of person. I read left to right, I do math left to right. But this has the right part on top, so we'll go ahead and put positive infinities in both of those places. Alright, now this one we only have the two x-intercepts at -1, 0, and at 2, 0. This one had a degree of 5 and a negative leading coefficient. This one, as we approach negative infinity, it was approaching positive infinity. And as we approach positive infinity, it was approaching negative infinity. If you got those backwards because I ordered them backwards, don't worry about it. Okay, how we doing? Are we feeling better about that part of graphing? Cool. All right. Okay, so this one has a root, a root, a root. So we've got one at -4. We got a root of x equals -4, x equals -2, and x equals 3.
Do we have to write the x equals?
I doubt they'll count off, but. Alright, root behavior. What is it doing right here at -4? Is it passing, tangent, or passing with inflection? It is just passing. Okay, so what is my factor? If this is -4, this is positive. And what is the exponent? Understood, 1. Okay, this one, what's it doing at -2? Passing. So what is my factor?
2.
Good. And this is an understood 1. Now this one is not passing, it is bouncing. So what is the math word that we use to describe that? Tangent. So it is tangent there. And it is tangent at, if this is +3, this is -3. And tangent tells me what about this exponent?
It's in the second row.
Very good. So, our equation would be x plus 4 times x plus 2 times x minus 3 squared. The last thing we need to check are the ends. It's rising and rising, which is a positive leading coefficient. So, I'm good. I don't have to put plus in front. Alright. Now, this one. Okay. If you didn't really need this column, did you? Because I gave it to you. If x squared is a factor, let's graph it. Let's graph it and then do the table. X squared tells me there is 1 at 0, right? And because it's squared, it would be tangent. And we really don't need this because we were given that, but alright. Okay, the next one is at -1. Okay, it's to the first power, so it will pass. The next one is going to be at 3. And it is, yes, it's going to be tangent there.
I was confused on the next one.
Yeah, you didn't really need. And the next one is -2. Now, this is an odd power that's bigger than 1. So it's actually going to pass with an inflection point. Or with inflection, that's fine. So, these tangent ones, if I had put like a 4 right there, that would still be tangent. If it's even, it's always tangent, even if it's not 2. So this one, if it's odd and greater than 1, it passes with an inflection. So that should happen at -2. This can be hard to graph. All right, let's figure out a degree. 2, 3, 4, 5, 10. The degree is 10. The degree is 10, and the leading coefficient is negative.
So they're both going down.
So they're both going down. All right. At -2, it passes with an inflection, so I'm going to try to make a whee. At -1, it's just going to pass. Oh goodness, I feel like I'm curling back on myself. All right, maybe problems. There we go. At 0, it is tangent, so we got a quick bounce back. And at +3, it is tangent, so we got to bounce back. This is hard to see. So I might show my teacher, inflection point right here. I'm actually writing it to show my students that there's an inflection point because I didn't do a great job graphing that. Okay, now the next ones, I graphed these on Desmos. These graphs came straight off Desmos. So I typed in equations and I graphed them on Desmos. So do y'all see something right there, and something right there, and something right there? This kind of looked like it was riding along closely. This is supposed to be an inflection. Do you see the squiggle? Okay, so this would be -1, this would be 0, this would be 1, this would be 2. Alright, so if I had to write the equation for this, I would start off with an x plus 1 for right here. And what power would that need to be? Very good. Okay, it's passing right through at 0, so it's just an x. I like to stick that in front. Okay, and then right here we've got a +2, so it's x minus 2. And because it's tangent, it needs to be squared. Okay, this one rises, so it's positive, so we're good. All right, this one is bouncing at 0, so that gives me an x squared. It is passing at 1, so it's to the first power, and it is passing at 2, so it's to the first power. So I didn't have any inflection points on this one, but it's going down. So what do I need out in front? A negative. All right. I'm sorry. Here you go.
Okay, you go.
Okay. Okay, and then we go back to the other stuff. All right, so, oh, you know what's really sad? It's not really sad. I'm really happy for the lady that did win. That lady yesterday came forward to claim the $700 million lottery. I bet she did shout, I won, when she saw she won $700 million. Yeah. But then she immediately came out and claimed her prize, which if I won $700 million, I would have met with a lot of lawyers before I came out and claimed my prize. I don't think that was too wise. Because anybody that's like her 8th niece, twice removed, is going to be calling her up asking for money now. Yes.
Do you know 10 and 11 are the same?
Yeah.
Well, if you got 10 right, you were good for 11.
I used to do 11 and I was 10.
Sorry about that. Okay. So this one, it is a negative under the radical, so it's I. The square root of 4 is 2. The square root of negative 1 is I. So that's how we think about it, as 4 times negative 1. That's 2I. Now the square root of 16 is 4. Now, we cannot leave our answer like that because complex numbers have to be in A plus BI form, which means the real part first, the imaginary part second. So we just switch it. Negative 4 comes first and a positive 2I comes second. Alright, so this one. When we divide this by 4, it goes in there evenly 8 times, but that's not what we care about. What we care about is the remainder. So I to the 34th is the same as I squared, which is negative 1. Alright, so since negative 1, yep. So since I gave you two of the same, let's do a U try real quick. And let's do like I to the 15th. Okay, so when we divide 15 by 4, it goes in there evenly 3 times, and the remainder is 3. So I cubed simplifies to negative I. Okay, that's the same thing we have to do on number 12. The first thing we do is we take that I squared and we simplify it. Did y'all distribute first or simplify first?
Distribute.
You distribute it? Okay, let's do it then. We'll distribute it, that's fine. So when we distribute, we get 3I cubed minus 2I minus 10. So I cubed is negative I. So this really is like 3 times negative I. So it makes it negative 3I. So this is real part first, imaginary second. So 8 minus 3 is 5. Take away 2 more is 3. Okay, now this one we're going to distribute. And then distribute.
It's not 2I, it's 21I.
Yours is 21I?
No, you multiply it. You
Yeah,
did
7I
7I times 3, you put 2I. It's 21. Do you not see what I'm talking about?
You have to do
7I times 3.
Yeah. You just put 2I.
I just threw a 1 in. Thank you. Thank you. Alright, and now we add like terms. Oh, wait, first we change this. Because I squared is like multiplying by negative 1. And now we add like terms. So we get 20 plus 17I. Alright, and finally we have division, which we change to multiplying by the conjugate. Alright, so basically it turns into 2 multiplications. Multiplying up top, multiplying for the denominator. Now when we multiply the numerator, we get 5 plus 3I plus 5I plus 3I squared. We multiply the denominator every time the outside and the inside are going to cancel when we multiply by the conjugate. These two are going to cancel. Now this I squared makes that a positive 9. This I squared makes that a negative 3. So my numerator simplifies to 2 plus 8I. My denominator simplifies to 25 plus 9, which is 34. Does everybody see that 2 divides into everything?
Yes.
So, we divide it out. 2, we're going to divide everything by 2. Divide by 2. I'm trying to change color. Okay, so that's what factoring out a 2 does. It divides everything by 2. So it's 1 plus 4I over 17. Or you could write it 1/17 plus 4I over 17. Yes, sir.
Didn't you say that we have to be able to simplify it now?
Yeah, that's why we did that part. Okay, so what we're gonna do, guys, Monday, I'm gonna do a quick review, and then we're gonna have a short little quiz test. On Monday in here. Then Tuesday we'll go over it before some of you have your test. I know some of you have your test first or second period. And you guys can stay after Monday if you want to go over it with me Monday afternoon.